Good morning. In continuation of previous video, in the previous videos I have explained the timer registers like TMOD and TCON register. So in this video I'm going to explain timer bar counter control logic. So that means the logic, counter logic are required to select counter or timer. As you know, it can be used as a timer or counter. So how do we configure it as a timer and how do we configure it as a counter? What is the logic? So here we know crystal frequency XTAL. I mean these are the pin which is used to connect the crystal oscillator. So oscillator frequency is used and that is divided by 12. That is divided by 12 since machine cycle have 12 clock pulses. And another one, this is the source for timer. This is the source for timer. And the source for counter is the pulses are received through TX. I mean T0 or T1 pin. That means these are the pins of port 3. That is 3 port 3.4 or port 3.5 pins. Okay. So first one is the source for timer and this is the source for counter. So if this bit is a 0, it is connected to timer source. If it is 1, it is connected to counter source. I mean here it is a simple switch. It is a simple switch. The contact is to the counter source or to the timer source depending on C bar T bar is equal to, if it is 0, it is at the timer source. If it is 1, it is at the counter source. So this logic is used to select the source for the timer or the source for the counter. So this is used to select a timer bar counter. And we use one more switch. Okay. It is to make timer on or off. Timer bar counter on or off. And then it is given to timer stages. So the switch is closed when the timer is on and the switch is open when the timer is off. And we know timer on or off depends on the gating control bit, gate bit. If it is 1, it is on when INTX is equal to 1 and TRX is equal to 1. And if it is 0, the timer is on whenever TRX is 1. So let's derive the logic to make the timer on or off. See, yeah, that means timer on or off depends on three things. One is TRX, gate, and INTX, interrupt pin. Correct? So first logic. See, this is the logic. Okay, first one. I mean, gate is equal to 1. Depends on INTX and TRX. See, this INTX pin is 1. If it is 1, whatever may be other input. Here we use OR gate. Okay, if this is 1, whatever may be other input, output of this is 1 and that is connected as a input to the AND gate. But so one more things, TRX should be 1. So that is another input to the AND gate. Another input to the AND gate. Whenever the output of AND gate is 1, the switch is closed, timer is on. The switch is closed, timer is on. And the second condition that is gating control bit is 0. Whenever it is 0, okay, and that is connected to NOT gate. So when it is 0, its output is 1. So OR gate is 1. Okay, OR gate is 1 and that is connected to AND gate and then it is 1. Okay, so other input TRX is, if it is also 1, output is 1, so the switch is closed. If it is 0, output of AND gate is 0, the switch is opened. Okay, so that means whatever may be other input, it is always 1 because so that is connected through NOT gate. So if you combine together, this is the logic. This is the control logic which makes timer on or off. Okay, it depends on output of AND gate. Input to the AND gate, one input is TRX, other input is output of OR gate. So input to the OR gate is NOT gate, that is a gate input through NOT gate, and interrupt input directly. Okay. So let's analyze this. Suppose gate is equal to 0. uh, Output of NOT gate is 1. Output of NOT gate is 1. So whatever may be other input. So output of OR gate is 1. Okay, OR gate is 1. As we know, whenever gate is equal to 0, timer is on when TRX is 1. So yeah, suppose if TRX is 1, so both the inputs to the AND gate is 1, so output is 1. So it switch is closed, timer is on. Suppose TRX is 0, output of AND gate is 0, so switch is open, timer is off. Clear now? So that is why we said whenever gate is equal to 0, timer on or off, it depends on only TRX bit. Okay. And suppose gate is equal to 1. Output of NOT gate is 0. So input to the input to the OR gate is 0. Its output depends on other input, that is interrupt pin. So suppose if it is 1, so output of OR gate is 1, and that is input to the AND gate. Okay. Again, output of AND gate depends on other input. Here one input to the AND gate is 1. Output depends on other input. If other input, that is TRX is 1, so output of AND gate is 1. The switch is closed. Timer is on. Suppose if TRX is equal to 0, even though interrupt pin is 1, TRX is equal to 0, output of AND gate is 0, so switch is open, timer is off. That means both should be 1. If either is 0, output of AND gate is 0, so that the switch is open, timer is off. Suppose TRX is 1, if interrupt is 0, output of OR gate is 0, that is connected as input to the AND gate, so output of AND gate is 0, the switch is open, that means timer is off. Clear now? So this is the logic used to turn on or off the timer bar counter. Okay. It consists of 3 gates: one NOT gate, OR gate, and AND gate. Okay. This is about timer bar counter control logic. So first one, it is to select timer or counter, and the second logic used to make timer on or off. So remember here X, okay, INTX or TRX indicates either 0 for timer 0 and 1 for timer 1. Okay. Now let's see the differences between timer and counter. So as we observed that timer is used to count the internal events and counter is to count the external events. And 8051 crystal frequency is used as the source of frequency for the timer. So as we observe, source of frequency for the timer is crystal frequency, and here source frequency is a pulse outside the 8051. Source frequency is the pulse outside the 8051 that increments TH and TL registers, and clock pulses are sourced from the oscillator through divide by 12 circuit. Here clock pulses are sourced from pin T0, that is P3.4 supplies pulses to counter 0, and pin T1, that means P3.5 supply pulses to counter 1. And here C bar T bar should be 0, then timer gets pulses from crystal, and it is 1, then the timer is used as a counter and gets its pulses from outside the 8051. Okay, this is about timer bar counter logic and the differences between the timer and counter. So I'll continue in the next video.